Good evening, this is Mr. Wintermelon, and today what I am doing down here is I am cooking an egg. So you might ask, what's the purpose of you cooking an egg today? So my purpose of cooking an egg today is to show you the effect that heat has on protein. As all of you know, the egg white is full of protein, and protein are all folded up into their three-dimensional structure. Very compact as well as soluble. Now, let me increase the heat of this cooker. Okay, now as I increase the heat, you can see that the egg white is becoming white. At first, it was transparent, or it is still transparent, but you can see that it is getting a bit opaque. So what is happening is, as we heat up the protein, they will start to unwind, exposing all the hydrophilic and hydrophobic end. And because they become unwind and become a linear strand of polypeptides, they will start to get tangled up with each other, and they will become insoluble. And because they are insoluble, you can see that the egg white will start to become opaque. So at first, they are compact in their three-dimensional structure. That's why they are soluble, as they are all folded up and they can dissolve. But now, as I apply more heat, the protein get unraveled, unwind, and become strands of polypeptides that are insoluble. And when they are insoluble, they got all tangled up, and this is what you see down here. So you might ask, how is it related to what we are going to learn, which is enzyme? This is because in this video, we are going to learn about 2 out of the 4 factors affecting the rate of enzyme catalyzed reaction, namely temperature as well as pH. To understand the effect of temperature and pH on the rate of enzyme activities, we must first understand how enzyme or protein becomes denatured. So as we all know, protein or enzyme are folded into their three-dimensional shape due to the bond that exists between the R group of the amino acid within each of the enzyme. Bond between those R group are not a very strong bond. Therefore, they are easily affected by pH as well as temperature change. And when protein or enzyme is exposed to high temperature or extreme pH, this will cause the enzyme to unravel or unwind, forming chains of polypeptides. So those chains of polypeptide does not have the active site required for the substrate to bind onto it. We say that the enzyme has been denatured. And as a result, no enzyme substrate can be formed and the reaction cannot be catalyzed. So now, let us first look at the effect of temperature on enzyme. So as the temperature increases until the optimum temperature, the rate of enzyme activities will also increase. At very low temperature, the enzyme is less active as it is moving very slowly, therefore the chance of it bumping into its substrate molecules will be low. As the temperature rises, the enzyme will also gain kinetic energy, and so does the substrate. And because they are moving faster, the rate of them colliding, forming enzyme-substrate complex will also be higher. Normally, but not always, a 10 degrees Celsius increase in temperature will result in the activities of the enzyme increasing by 2 times. The rate of enzyme activities will increase until the optimum temperature, whereby the rate of reaction is at its fastest. However, as most enzymes are made up of protein, they will start to denature after its optimum temperature. Therefore, the rate of reaction will drastically decrease beyond the optimum temperature, as the enzyme starts to denature and lose its active site. At very high temperature, the enzyme will lose its ability to catalyze a reaction. As for pH, the bond within the enzyme can be disrupted by extreme pH level. The pH where an enzyme functions at its maximum rate of reaction is known as the optimum pH. Whether it is increase or decrease of pH beyond its optimum pH range, it will cause the protein to unfold and lose its active site and becomes denatured. So enzyme substrate complex cannot be formed, therefore the rate of reaction will decrease. Different enzymes have different optimum pH, and normally an enzyme have a very narrow range of pH. Under extreme pH, the enzyme will completely denature and the rate of reaction will fall drastically. So different enzymes have different optimum temperature and pH, while the optimum pH of different enzymes in human can vary widely. The optimum temperature of human enzyme normally range from 40 degrees to 45 degrees Celsius. So this is all for the two factors which affect the rate of enzyme reaction. In the next video, you will learn two other factors which will affect the rate of reaction.